Yo, Chuck.
What the chuck is up, YouTube? In this video, we're going to go over Gnome Sort. Gnome Sort is kind of a funny algorithm that earned its name because we're going to use this index value to compare adjacent items to do our sorting. And the people who created this algorithm likened that moving of the index to a gnome moving flower pots to arrange them. So this is kind of a slow algorithm. It clocks in at a time complexity of O of n squared, but it is very easy to learn, and I'm going to show you that now. Let's get started. So like always, first thing I'm going to do is just make a function called Gnome Sort. It's going to take our unsorted array. I'm going to return that array, and then now let's console log a function call of Gnome Sort with a unordered array passed in. We could do something like this. Okay, I'm going to run this code. Running the code, and we get back our array. Excellent. Okay, so like I said, we're going to have an index value, which we're initially going to set to 0. So we'll say index equals 0, and then we're going to loop over the data, and we're going to compare adjacent items. But index, although we're starting at 0, we never want it to be 0, actually. It always must be 1 at the least. That is because we're going to compare adjacent items. So we're going to compare 5 and 1, 4 and 5, like that. So we're comparing adjacent items, and the array at index is actually going to be the value in front. So what that looks like is I'm going to make a while loop and say while index is less than array, we're going to fire this while loop. Now I need to make sure that index is never 0. So I'm going to say if index equals 0, index equals 1. And use the assignment operator there. Okay, so here's where we're going to do our comparisons. I'm going to say if array at index is greater than or equal to array at index minus 1. Just like I told you before, we're comparing the item in front, which is the array at index, to the item behind it, or trailing behind it, array at index minus 1. And let me make sure I put my brackets in the right spot. Okay, so this is saying, hey, if the value in front is bigger than the value behind, then that's actually ordered and that's good. Therefore, we can increment the index value and we can move on. Because remember, this while loop is going to stop firing once index is equal to array. Okay, so this should be array.length, by the way. If I just said index less than array, that wouldn't make any sense because it would be like, hey, are you talking about the array length or the object of array in JavaScript? So make sure you get that right. Okay, so we're going to increment the index if the adjacent items are sorted. What if they are not sorted? So if the array at index, the number in front, is less than the number trailing behind it. So I will say, if that is the case, I'm going to perform a swap. Let's make a temp variable to store the value of array at index. Then I'm going to set array at index to array at index minus 1. And then finally, I'm going to utilize this temp variable, which I just stored the value of array at index. And I'm going to set array at index minus 1 now equal to that temp variable. The reason we create a temp variable is because if I was to not have the temp variable and I said array at index equals array at index minus 1, and then I said array at index minus 1 equals array at index, now there's no swap actually happening. You just have both numbers equal to whatever the value of array at index minus 1 was. That is why we use a temp variable to store the value of array at index. So let's uncomment this code, and now we have performed our swap correctly. Okay, so this is going to be where Gnome Sort is kind of slow. every time we perform a swap, we're actually going to decrement the index. And what that's going to do is it's going to bring us back. So if right here, for instance, we're going to do this comparison right here of 4 and 5. I'm going to say, well, 4, right now we're at index 2, by the way. So I'll say index 2. So we're right here, and then at index 2, which is 4, and then we're comparing it to index minus 1, which would be this 5 right here. So we're going to say, is 4 less than 5? Yes, it is. And then we're going to perform that swap. So what that's going to look like, we're going to perform a swap of 4 and 5, just like this. But now because I've performed that swap, I incur that decrementing of the index. So now my index is actually going to be equal to 1. So what does that mean? That means I'm back here for my next comparison. And I'm going to compare these two numbers. I'm going to say, is 1 less than 4? Yes, it is. Then I'm going to increment my index. So then now my index is incremented by 1. So I will have the same array, for instance, but now my index value is actually incremented by 1. So now I'm back to index of 2, which array at index of 2 is 5. And then I'm comparing the number trailing behind 5, which is 4. And we do the same process. Is 4 less than 5? Yes, it is. So I can increment my index again. So let me just copy and paste this value. So I'm going to increment my index again. Now my index is at 3. Well, array at index 3 is actually 2, and the number trailing behind 2 is 5. Is 5 less than 2? No, so we need to perform a swap. So we're going to perform our swap. Let's swap 2 and 5. 2 and 5. But we must decrement index to 2 again. So now index is 2 because we've decremented it. So if I go back to index 2, now that's where the number 2 is, and the number trailing behind index 2 is 4. I do the same thing. I do a comparison. Is 4 greater than 2? Yes, it is. I need to perform a swap. So I perform that swap. 2 and 4. Actually, let me just copy and paste this because I have the old version. Okay, so I'm going to perform the swap. I swap 2 with 4, and then I must decrement index again. And now it's at 1. So you can see we're sorting, but we keep decrementing that index, and the index value is what's going to eventually get us to get out of this loop, this while loop, because once index reaches the same amount of elements as there are in our array, then we'll get kicked out. So you can see how Gnome Sort is kind of inefficient in this manner. But let me return the array to make sure it is sorted. And you can see it is. Let's add in some funny values to try and break it. Let's do another 2, another 4. How about that? And it does work. So it is working. Let me delete these values I just added. Run it one more time. Okay, so just like I showed you right here, I'm kind of walking it out step by step. It might also be helpful to do a console log statement. So I think if we console log what the array is, and then also I'm going to console log, actually let's do it like this. I'll use template literals. I'll say array, pass in the value of the array, and then I'll say array at index minus 1, array at index first. So I'm going to console log these values so we can see what exactly is happening each iteration of our while loop. So here's where I'll actually put array at index minus 1, array at index minus 1. And notice I am putting this logic after this if conditional because index will never equal 0. I want to see what it looks like when it equals 1. That just makes sense. Okay, now let's run this code and see what happens. And you can see all the iterations of our loop. And let's look at the first one here. So initially we're at 5. Also I'm going to put in the index value. That would be helpful. So I'll put in index like that. Just like that. Okay. Oh, make sure you put it inside your template literals here. What did I do wrong? Oh. Index. Oh, I have an extra bracket. Or do I? Oh, this is part of this. Okay, whoops. Sorry, guys. So index. I had this, I was writing inside the bracket for this index -1. So sorry about that. Okay, so here we are back at our code. Let's look at the first iteration. Again, I'm going to be comparing 1 and 5, and we know that a swap does not need to take place, so we can just increment our index. So here we are, the next iteration. You can see we've incremented our index to 2. Now, because our index is at 2, we're going to compare 4 and 5. Is 4 less than 5? Yes, it is. So we need to perform a swap. Here we perform our swap, and notice we've decremented index by 1, so now index is equal to just 1. And we are comparing 4 and 1 again. So notice how we're going backwards. And this matches the logic we have down here, right? So that makes sense. We would expect that. Now we're going to compare 4 and 1. They're in the proper positions. We can increment index and go to another iteration of our loop. Now we're at index 2. We're comparing 5 and 4. They look like they're in a good spot. So just like we are down here, we're going to increment the index one more time. So now our index is at 3. And now we're comparing 2 and 5. We need to make a swap here. The swap happens, and we decrement our index. But then also, we're comparing 2 and 4 now, and 2 is still less than 4, so we need to keep swapping, so we're going to decrement our index again. And here, you can see we're getting closer to actually having a fully sorted array, but it's very expensive. This is a very slow algorithm. Because every time we make a swap, we're forced to go backwards, right? So that is why when people talk about Gnome Sort, it is not a practical sorting algorithm. It is very expensive. So yeah, that wraps it up for Gnome Sort. If you found this video valuable, please make sure to like and subscribe, and I will see you guys in the next one.